Hello, dear students. Now we start the fourth practical lessons of the high mathematics subject. My name is Makovkin Sergey Yurievich. Let's start. The previous homework you have about the straight line on the plane. The homework were first example. You will have several expressions or several equations of the line, and you need to select from this set of the equations of the line, parallels and the perpendicular lines. So, first of all, here you need to write all the equation of the line in the normal form and to take or to find the slope values for every lines. Here we have a six equation of the lines. 5x minus 2y plus 3 equal 0. We write in normal form and find the k-slope value 5 by 2 for the first line. For second line, rewrite minus 2 by 5. Third, 5 by 2. Fourth, minus 5 by 2. Fifth, minus 5 by 2 again. And the sixth line, 2 by 5. And so, if you watch my lecture previous about this topic, about the straight line on the plane, the parallel line condition, when the value of the slope are equal, ki equal kg, and so we need to find which values of the k-slope value are the same. Now here, as I have find k1 will be equal k3, so first line and the third line are parallel lines, and again k4 and k5 are the same too. 5 line parallel for the fourth line, parallel for the fifth line. Perpendicular line condition, when the multiplicating of the slope values are equal minus 1. And so we can find more cases. For example, k1 multiply k2 will be equal minus 1. So we can set that line number 1 perpendicular to the line number 2. 3 and 2, as I find. 5 by 2 multiply minus 2 by 5 will be get minus 1. So line 2 will be perpendicular to the line 3. And the same fourth and 6. Fourth and 6 minus 5 by 2 and multiply 2 by 5 will get minus 2 and minus 1, of course, and 5 and 6. Minus 5 by 2 multiply 2 by 5 will be, in this case, will be get minus 1. And so that is all about the perpendicular and parallel lines. The second exercise was about a triangle, and we need to find the height from the A points to the BC side AD, or maybe equation for all the sides, and MN mean line, which is goes through the center of AB to the center of BC. So this is ABC 3 points on the two-dimensional plane xy. So we have some coordinates for the A, B, and C points, and we need to construct the lines AC. AC, we can see that y values on A 0, on C 0, and so we can draw on the xy plane. The equation for the AC will be y equals 0. AB, for AB, we need to use a two-point expression, two-point equation, x minus xa point, xb divided xb minus xa point, and for y the same, y minus yk divided yb minus yk. We put the directly these values, and we get x plus 2 divided by 4 will be equal y divided by 4, or we can rewrite y will be equal x plus 2 for the AB line. The same situation with BC line. We know the coordinate of the BC, B and C points. We use a two-point expression for the line, put the values, and we get y equal minus 2x plus 8. What about the height line AD? AD need to be perpendicular for BC. The equation for BC we know, and we know the BC slope value, and during the perpendicular condition, the series condition, K slope value for AD multiply K slope value BC, multiplying products will be equal minus 1. The BC value we know, it will be equal minus 2, and so KAD slope value, we find that it would be equal 1 by 2. And so we know A point, we know KAD value, and we use the expression for the line by the two values, 1 point value and K slope and slope value. So YK will be equal KAD XA plus B. We put YK value, KD value, XA value, so we found B value. If we found B value, we can write the line equation for the AD, Y equal 1 by 2, it is the KAD slope value, X plus 1, it is, it is the B value. And that would be the answer. Then BC or what? Length of AD. How to find length of AD? We need to find what? DAD. I don't remember. We have a BC line equation, and we have points of the A. It is a formula from the lecture. If we know one point, and if we know equation for the line, we can directly find the smallest distance from this line to the point. And so this is, we need to put this coordinate of the point divided by the 2 plus 1, and they directly can find the distance, or distance from BC to the A, or in the other terms it would be the size or the length of AD. Then AE. AE, the same is E, or in other terms, N. Yes, it would be the center of BC sector. Now, in these terms, we of course we know the points of A, we know the points of E, and and defined as a Euclid distance, the size or the length of the vector AE, and we have some value. Mn, it is mean line. We know the E coordinate, or it is the same, the n coordinates. We can find m coordinates at the center of AB sector, and we know coordinates of the m, we know coordinates of the n point, and now we use a two-point equation for the line, and we find that y equal to, it is the line equation for the mean line Mn. This is very easy task. And the next topic, functions. The functions. So the functions, this is when one y letter depends from the x letter. One value depends from the another value. Now, for example, the first example number, find the value of the function. Let the function will written in form 2x in square minus 1 divided by x plus 3. We need to find what? X or f in the point of the 1. So we need to put 1 in the x and find something. So we write 2 multiply 1 in square minus 1 divided by 1 by 3, and we get the answer 1 divided by 4. The same example, f at x equal cosinus or cosinus from the 2 of x. We need to find f from 0. Cosinus of 0 would be 1. F from p by 2, or p by 2 it is 90 degrees. Cosinus from the 2 multiply p by 2, it would be cosinus from p. As we know from school, it will be equal minus 1. F from p by 4, it would be cosinus 2 multiply p by 4. Cosinus from p by 2 would be 0. F from p by 12, or cosinus from the p by 6, it would be square root 3 divided by 2. Okay. The example number 3. Find the domain of the function. Domain, it is a region which values can take the y value. The y value. So, for example, y equal 3 multiply square root 4 minus x in square. We know that there is some condition on the under square root expression. The expression under the root with the even powers need to be greater or equal than 0. And so from this condition we find the x's. 4 minus x in square greater or equal 0. Rewrite x in square less or equal 4. Or in other form, x take a value from minus 1, minus 2, and can equal minus 2 to the 2 can equal 2. In other form, 5 minus square root x minus 2 divided square root 5 minus 6. This case, for numerator, expression under the root in the numerator need to be greater or equal 0. So we write x minus 2 greater or equal than 0. For denominator, denominator cannot equal 0. So we are not able to write the sign of equal 0, and the expression under the root need to be greater than 0. From these two conditions, x less than 5 or x greater or equal to, we write an answer less than 5 without point of 5 greater or equal than 2. So we write that x can take a value from 2 in square brackets, because x can equal to the 5 in the arrow brackets, because x cannot take the 5 values. The third, y is equal root in the power 3, 1 minus x plus x minus 3 root of the power 3. It is an odd power of the root, and so for this in the lecture there was a rational form of the function. If the odd of the power of the root is the odd, the x can take any value from minus infinity to the plus infinity, or from real number set. Again, the number for exercise y equal 2 in power x. So you need to watch the lecture again. X can take any value from the R real number set. Then exercise on another topic and another question. Show that function y equal 3x minus 4 increasing on the R set. R set, it is a real number set. Let we take two any values on the R set, real number set. Let x2 will be greater than x1. We need to find f from the x1. No, of course it would be 3 multiply x1 minus 4. F from x2, it would be 3 multiply x2 minus 4. And we need to see the value of f from x2 minus f from x1. So it will be, we put this value 3x1 minus 4 minus, in brackets, 3x2 minus 4, and we get 3x2 minus x1. But on the initial hour conditions, x2 greater than x1. So in another case, the value x2 minus x1 will be greater than 0 or will be positive in any case. And in that case, that this value would be positive, then the value f from x2 minus f from x1 will be positive. Or in other terms, we can rewrite it that f from x2 will be greater from f from x1, and if x2 greater than x1, and then f from x2 greater from f from x1, this is you need to see the lecture again. This is the definition of the strictly increased function. Then another type of the exercises and investigate the functions even and odd parity. So you need to see what type of the functions we have. In the lecture you will find even or odd, definitions. First example, y equal x and 4 minus x and square, let it f at x, and we need to check even parity. If f from minus x will be equal f at x, it is a definition of the even function. Here we check it, and of course f from minus x will be equal f from x, then it is even. Second case, x in cubic divided x in square plus 1. We need to check the definition of the odd type of the function when f from minus 6, if it equal minus f at x, we already check it for this example. It is odd type of the function. The function like this, x in square plus 4 divided x minus 1. Here we need to again check for the odd parity and even parity, but no conditions would be right. So this case called general type of the functions, and that is all. For type y equal 3x minus x in square plus 2x in cubic. Again, in that case, we can check even parity, even type, odd type of the function. Of course, this general type of the function. F at x, 2 in power minus x in square. It is even type of the function. F from x, a in power x minus a in power minus x divided by 2. It is, as I remember, called hyperbolic sinus. A greater than 0, a doesn't equal 1. We check f from minus 6 and found that it equal minus f at x. By the definition, it is odd type of the function. The function like with logarithm from the something y minus 6 divided 1 plus 6. It is haven't checked on the odd types of the function or even type of the function. It is only a general view. So here we talk about the definition, about how to use definitions that we discuss in our lecture. So example number 6. Write y as a function of the variable of x. No, it is a simple type of the examples. For example, the first, y, it is z in square, where z, it is x plus 1. So we rechange that letter for the x plus 1 and we get y equal x plus 2 in square. Then y, it is z in square, where z equals sinus x. So of course y will be equal sinus in square from x. Another type. Y equals sinus z, where z x in square. Y, it is sinus from the x in square. Fourth, y, it is z in square, where z cubic root t plus 1, where t equal 2 in power x. And so we put 2 in x, it is t, and the cubic root put in the z. And so equal will be square root cubic root from the 2x plus 1 in the square. Again, the same example, y equals sinus z square root 1 minus t logarithm from x, and so we put and we get sinus from the square root 1 minus logarithm from x. Seventh, open the chain from the elementary function. Y equal cosinus in cubic x. So we need to write y, it is the letter z in cubic, where z it is cosinus. the same example as the example number 6. Second case, y, it is root and power 4, 1 plus x and square. And we write y, it is root and power 4 from the z it is 1 plus x and square, where x and square it is t. And so the same example, I don't want to read this. Your homework, this is the homework for the next lesson. First, find the value of the function 2x plus 1 divided x and square plus 1. You need to find the value of the function f from x minus 1, 2, and 1. The second, find the function domain. First, y, 2 divided square root 25 minus x and square. The second, square root from 3 plus 6 plus root of the fourth power 7 minus 6. The third example, y equal x multiply arcsinus x. And the next one, the fourth, here I am right, y is equal in numerator 1 plus x divided by denominator 1 minus x. The third example, the same as in this practical lesson, show that y equal minus x divided by 2 plus 3 is decreased on the R set. And the fourth example for you, investigate functions on the even and odd types of the parity. F at x equal first x in square plus 2 divided x in square minus 4. The second, 4x in cubic minus 2x in square plus x plus 2. Third, x in cubic minus x divided x in square. Fourth, y equal logarithm 1 minus x if y equal 2 in power x in square minus x in fourth. And the sixth case on this example, f at x equal a in power x plus a in power minus x divided by 2. It is a function called hyperbolic cosinus. So that's the end. You need to check where is odd, even, or a general type of the function. Thank you for your attention, students. Good luck for you.